Hi guys, welcome to the new tutorial on Java multi-threaded programming. In this video, we will see how to run tasks in thread and send a callback when all task is completed. Concurrent programming is essential for all modern systems. Android by design is asynchronous, so getting strong in concurrent programming is a must for all Java developers. As you can see in the diagram, there are three tasks. These three tasks run in parallel, and when all of them are finished, we send a callback. What are some of the use cases for this kind of a model? In Java, we need to synchronize data with the server. There are various types of data, and these data are sent to the server through APIs. We want that all these tasks of synchronization, when complete, a certain action should happen. For example, if we are showing a loader to the user, then that loader is removed. For the backend, this model could be utilized while saving data in several different mediums. For example, in database, file logs, and cache. And when the data is stored in all these categories, we send a response on their completion. For understanding and building a model for multi-threaded problem statement that we just encountered, we need to understand two important things: process and thread. So a process is an instance of a computer program that is being executed. So a program that is running is a process. One Android application is a process. So WhatsApp is a process, Facebook is a process, and so on. In Android, when an application starts, the Android system starts a new Linux process for the application with a single thread of execution called main thread. In Android, each application starts with a single thread, and then we can create various other threads so that we can utilize the CPU time and the processors. So in the diagram, you can see a process contains various threads. Now let's see what is a thread. A program can contain two or more parts that can run in parallel. Each part of such a program is called a thread. Second thing is that thread help in utilizing multi-core processors. They also reduce the ideal CPU time of a single processor. But there is a downfall that creating too many threads will slow down the execution. At a given time, only a few threads run in parallel. Others wait for the CPU to get free. If you can see in the diagram, a thread, this is a life cycle of a thread. So a thread starts, it runs and it can sleep, it can wait, and then its execution ends and it becomes dead. In Java, a thread can be created by two ways. First is thread subclass. So for creating a thread by using the method of thread subclass, we will create a class that extends thread and we will override its run method. We will create the instance of that class and call it start method. When we call the start method, the thread starts to run and it calls the run method implementation of our thread class. Second method is to implement runnable. So we can create a class that implements the interface runnable, whose run method we have to define. We can create a new thread and pass the instance of the class that implements the runnable, and when we call the thread.start, it will execute the run method. Now let's see how to build the programming model to solve the given problem. Let's analyze the problem first. In the problem, we have to create task. This task will be executed by threads, and then there will be a central mechanism that will notify when all the task is completed. So here we can identify three components. First is task, second is worker, and third is executor. Task is the code that we want to run in a different thread. So task will be a runnable that we will pass on to a worker. A worker will be responsible for creating thread and it will execute the runnable task provided to the worker. Executor will be responsible for running the workers and broadcasting the completion of the tasks. This is one of the way to solve the problem, and programming is a art, and a program can be beautiful and ugly. So whenever we are writing a program, we must spend time in defining the structure of the program and coming up with a good model. The entire code can be found using the above link. You can use the below link to practice the code which is written in the above link. Now what I will do is I will set up the requirements for running this project locally. Briefly I will explain the procedure. So what we will need to do is we will need to open the terminal, create a directory. I call it MindDocs multithreading. We have to go to that directory, then we have to generate a Java library Gradle project. We will have to open that project in IntelliJ IDEA, then we will have to create a class called main, and then we will see how to implement our model. Let's move ahead of setting up the local environment. We will have to open the terminal, we will have to run command mkdir. Okay, now you can see we have created a directory called MindDocs multithreading. Now let's move to that directory. Now we are in this directory. To generate the Gradle project, we will have to run this command. Make sure that you have installed Gradle in your system. So we run Gradle init type Java library. It will take some time, and when you will see that folder, you will see a project generated. Now we will have to open this project in IntelliJ IDEA. This is a free IDE by IntelliJ which we can download. Now we will have to open that generated project. Use all the default setting, click OK. Now if we see the directory structure, we can see a directory source which has directory main, Java, and then a class that is generated called library.java. Now this library is the auto generated by the init task. You can name it anything. I like to name it main. So what I will do is I will refactor it. Call it main. We have defined our main class which has a main method. Now let's define our next class, worker. Create a new class called worker. As you remember that we had defined task, worker and executor. Tasks were simple runnables whose run method we can call. So this worker will get a task as a runnable. Create a thread in this class. Okay. Now define a constructor. It will create a thread. Now for this model, what I am going to do is I am going to make this worker work as a runnable. Why I am doing it, you will understand it very soon. Okay, so worker now implements runnable which brings the run method. Now I have created a thread and I will pass the instance of this class. So when this thread starts, it will call the run method of this worker. Now worker's run method is called, but we have to execute task. So what I will do is this worker will receive a runnable. We will call it as task. Okay, we will save this task in the local variable. Okay, so now when thread starts running, then it will call the run method of the worker and worker will call the run method of the supplied runnable task. Okay, now I don't want this run to be called explicitly. So whenever we want the executor to start the worker running, we will supply a public method called start. Now this will start the thread. So there is a problem here that workers thread can be called multiple times. We should not call thread.start multiple times. So what I will do is I will safeguard this start method. For doing that, I will have to keep a flag, a boolean flag. Now I am going to introduce you a variable, a class called atomic boolean. I will call this variable as started. So what is atomic boolean? It is a boolean value that can be read and updated atomically. What it means is that read and write operations are synchronized between threads for this boolean. It will not happen that one thread is writing while the other thread is reading. So we are using this atomic boolean so that the thread always read in a synchronized fashion. So now what I will do is I'll check here that if started.get. If it's not started, then I will only start the thread. But what we have to do is only first time it has to start, and then when it start it has to set the boolean variable. So this atomic boolean has one method called get and set. We'll have to initialize it. Okay, or we can move the initialization in the constructor. So now till now we have created a thread, a runnable task and a boolean value to control single start for the thread. We created a new thread which will execute this run method. Then we created atomic boolean with initial value false. When someone calls start, it will check the started value. If it's false, then it will make it true and return false, and it will start the thread. Now let's define our next class, executor. Now executor will be a thread that will create workers for the task, and when all of these workers are done with the task, the executor will send a callback. So what I will do is I'll make it a thread by extending the class. Now this executor need to store what workers are there. So I'll create a concurrent linked queue. Which will hold workers. Okay. There will be a callback that will broadcast that all task has been done. So let's define a callback. Define an interface called callback. In this callback, we'll define a method called onComplete. So now we'll pass the instance of a callback to this executor that will update the completion. These two has to be passed. Y has to be passed. Okay. Let's see now that we want that executor should execute the task by creating workers. So this executor needs a list of tasks, and when it executes, it should not be interfered. So what we will do is we will create a builder pattern for adding the task for execution. We'll create a builder class This builder will accumulate the tasks. We'll create a list of runnables. Okay. We'll call tasks, and this builder will also be responsible for taking the callback. Now we'll define an add method that will add the task into the list. We'll return the builder. Add method which takes a runnable called task. So tasks dot add task. So we are accumulating the task provided to the builder, and we will return this as is common in the builder pattern so that it can keep adding, and it will also return callback builder. This is a callback method. Okay, so this will take a callback interface that we have defined, save the callback, okay, and then return. Okay, now it will have a build method that will instantiate the executor. We will return new executor, pass in the task. So we have to define a constructor, okay, for the executor. Now this executor will take the list of runnables called tasks and the callback. We'll pass in the tasks and the callback. Okay, now a very important concept. We will use countdown latch. What is a countdown latch? Countdown latch is a synchronization aid provided by the Java concurrent package. It helps us to manage threads in a way that one or more threads wait until a set of operations performed by other threads complete. Simply say there can be 5 threads and there will be one other thread. So one other thread will wait for these 5 threads to end using the countdown latch. Let's understand it by implementation. So we'll just define a class variable. Okay, so first we will create workers. And we will create the latch. Countdown latch takes number of lashes as an argument. We will say that the size of the task, number of tasks is the number of lashes which has to be count down. It means that number of times latch should be called before the calling thread executes. We'll understand it with the example. Okay. So now we'll have to create our workers. We have supplied the task. Now we have to create workers. Now what we will do, we'll iterate over the task. Okay, now we will create our workers. Workers take task and callback and the task. Okay, now this executor has defined a countdown latch. We will have to pass this latch to the workers to inform that it has completed. So what we will do, we will supply the latch in the worker. Okay, we'll save this latch. Call latch.countdown. this lash.countdown will broadcast that it has completed. Now we'll have to pass our lash here. Now we want that this worker should start working on demand. So we'll create a method called execute. Okay. When execute is called, it will start the thread defined by the executor. Okay. Now for this thread, what it will work is defined in the run method. So we'll override the run method. We don't need to call super here. We just want our code to run. Now when the executor's execute method is called, it calls the start method, which in chain calls the run method. When run method is called, the thread is running. So what we want is that when executor starts to run, we start the workers, and when all the workers are completed, that will be identified by the countdown lash, then executor should send a callback. So in the run method, what I will do is that I will poll this queue and call all the workers start method. So what I will do is I will call while true. I'll get the worker from the queue. Call the poll method. Okay. Then for the termination condition of the while loop, I'll check worker equals null, then break. The workers that we have found will call the start method of the worker. Now, after calling the start method of all the workers, this thread of the executor will wait. To wait for all the workers to complete, it will call lash.await. You see, you have to handle the exception of interrupted exception. Okay. Now lash.await makes the thread wait till all the worker calls the countdown of the lash to the count we have defined as task.size. So all the workers will call countdown, and when it reaches the count we supplied, countdown lash await will be over, and this thread will start to execute after this line. So now we'll check this. Callback not equals callback dot on complete. We have checked not null because we have supplied into the builder, so it can be optional. In the main method, what we will do is we'll create an executor. Okay. We'll call the builder, then we'll call the add runnable. Now here I am going to use lambdas. So lambdas we'll have to pass the run. We are passing the runnables. So in lambda we will define it this way. So we added one task to the builder. Now what I will do is, as a identifier, I will print out this message. I'll call it task 1 start, and then I will deliberately cause the thread which is running this task to sleep for say like 2 seconds. Now we'll have to handle this interrupted exception. Now after this thread starts again from sleep, it will call that it's completed. Now similarly I will add few more tasks to it. Let's say we add 3 tasks. So task 2 starts, it waits for let's say 500 milliseconds, task 2 complete, task 3 starts, wait for let's say 1 second, task 3 complete. Now let's pass a callback. This callback will also supply a callback, then call build, after building execute it. Now this executor will create 3 workers for these 3 tasks, and when execute is called all 3 will starts to run. Now this application has a main thread which after calling execute ends, so this program will end. So we will have to keep main alive. In Android, main is kept alive by the system itself. It's a Java program, we have to keep the main alive till our tasks are completed. So for keeping it alive, what I will do is that I will write while, and I will create a flag here called atomic boolean. I'll call it processing, new atomic boolean, and processing. Now while it's processing, it will keep on running. Okay, if it's not processing, it will end. Okay, keep running. When it ends, I would like to print out a message that program terminates. Okay, so let's check. We have a main method, a flag for keeping the main thread alive, create an executor through a builder, provided 3 tasks, and a callback. Now this processing should end when we get all this task completed that we will get in the callback. So in the processing dot set false. So now when callback is received, all this task is completed, and when main thread accesses processing, it will exit this while loop and then terminate. Okay, let's check. Click main, right click main, and call run main method. Oops, there is a null pointer exception here. What's the exception? In line 24, task is null. Okay, so we didn't save the task in our variable. Now let's run again. Yo, bingo. So now we see that task 1 starts, task 3 start, task 2 start, and then task 2 completes first, task 3 later, and task 1 last, and the program terminates. So now we have implemented the model for synchronizing task completion. If you will see the example that I posted on the URL, all these classes are listed in one class. This is because we have to run online, so all these classes were written in one class itself. Now you can use this class in your Android code, in your Java program for backend, or anywhere you are using Java. So in this tutorial we learned many concepts of concrete programming and to enforce synchronization across threads. I hope you have enjoyed this tutorial. The next tutorial we will cover callables, future and future tasks. All of these help in passing the result to the caller thread when the worker thread finishes. As we saw in runnable, that when the run method, in thread also, when run method is executed, nothing is passed from that thread to the calling thread. So callables help resolve this problem. Then we will cover thread pull executor. Now here in this example we had multiple tasks. Suppose we had hundreds of tasks, and this system will then create 100 threads, which is not good because creating too many threads slow down the execution, because thread creation has an overhead and thread switching is also has an overhead. So thread pull executor creates a fixed number of threads and uses those threads to execute the tasks. After that we will look into monitor and locks. So locks help in synchronizing threads based on various criterias. So see you next time, and do visit mindocs.com. We have innovative ideas, great writings for all developers to read. If you want to get in touch with me, this is my Twitter profile. Thanks. Bye bye.